Ladies and gentlemen, welcome to this latest teaching session in the course on technology and the future of medicine. Today, Osmar Zaiane is giving the main presentation. I just have a few remarks, mainly about the Sony Aibo robotic dog, which you've just experienced. But just to give you some general objectives for the AI lectures, there are 4 of them. 3 are given by Osmar Zaiane and 1 by Patrick Pilarski. The objectives to introduce you to the basic elements of AI, machine learning and data mining, to introduce you to the basic concepts of the influence of AI on the exponential future, including the concept of unfriendly AI and the technological singularity, to provide you with concrete examples of AI in everyday life and in medicine. Now, it may seem to you like artificial intelligence is just another subject in the course, but it's like probably way more important than all the other subjects, because it is quite likely that unfriendly AI or AI gone wrong represents the greatest existential risk out there. So it is possibly the most important area addressed in this course. And although we have 4 lectures on AI, we talk about AI almost every single class period. So it shows how important this subject is. And AI is very important to this singularity, but that does not mean that all AI researchers believe in the singularity. There's considerable variation in beliefs about that. You can read about AI in books, but when you experience it firsthand, like you just did with the robotic dog, it's a bit more vivid. It's amazing how much of a relationship you can strike up with the Sony Aibo robotic dog, despite the fact that it represents 2005 technology. Their last production run was in 2005. And imagine what the capabilities would be today if Sony had continued developing the product over the past 9 years. One thing I think is that the joints, which are very noisy and kind of distracting, would have become silent by now. And the movement's very fluid. This is just my own personal fantasy about what the 2014 version of the Sony Aibo dog would have been if development had continued. It's a very popular part of this course, and we have many, many videos over the past 6 semesters of students interacting with that dog. Now, you may think that's just an ordinary dog, but I want to tell you some life experiences that dog has had that you haven't had. That dog has visited Leonard Cohen's house in Montreal, attempted to make Leonard one of his owners and to map Leonard Cohen's kitchen. And also we discussed with Leonard a lot of philosophical things about the ownership, how many owners a robotic dog could have, and whether a robotic dog had a concept of evil, and a bunch of things like that. And Leonard believed that the dogs would somehow find a way to get big enough to do harm. This was his idea, what would happen in the long run. I went to Syria in 2004 and was a guest lecturer at the University of Aleppo, and the dog went along. And I was speaking in a room not unlike this one, but the lighting was different in that the space between the audience seats and the podium was quite well lit. And all the time that I was lecturing, even though the audience seats were dark, the dog was having quite a good time. It's the most successful experience I think I've ever had of the dog really acting, intelligent. That's the main problem, is you bring something that's supposed to be smart and it doesn't look that smart. But that time, it turned out well. We made many plans. We got back here, and of course, things went from bad to worse in Syria, and we were not able to make use of any of the plans we made. Also, Ross Lockwood is thinking of taking that dog on his Mars simulation exercise from late March to late July, so in a sense that dog may also go to Mars. So quite an experienced dog. These are the main features. It is internet connected. You can send messages through it. You can get all sorts of information via the dog. Aside from other things, it is Wi-Fi enabled. The experience of the Sony Aibo dog for an AI researcher and for an ordinary consumer is entirely different. Robo-soccer is the main interesting activity that these dogs were put into by computer scientists, and I think they continued to be explored after the consumer interest in the Aibo in Canada died, which occurred very quickly. So the dog can keep going forever. It can detect the fact that it's tired, that it has a low voltage, find the recharging bed, charge itself back up, get up off the bed. So as long as you keep the charging bed plugged in, it can keep going forever and is sort of autonomous in that way. But it doesn't seem to be a very Canadian product for Canadian consumers. In 2002, Sony was selling them here, but by 2003, because no good Canadians were buying the product, they stopped selling it. And so the only way I was able to get this dog was by flying to the US, staying at a hotel until the dog was delivered, and then flying back. They had all sorts of buying around rules where you couldn't ship directly from Sony US to here. So anyway, and who's it for? You may think it's for a child, but actually the ears and tail come off in seconds. And so it's completely impractical as a child's toy. It's a toy for adults, and what kind of adults? Affluent young women. Particularly Asian affluent young women. Even the men who bought them mainly for the women in their lives, it is said. And so I've been teaching this for a long time, and of course I myself doubted whether that was really true. Then I went to a residence retreat where the young doctors in training in anatomical pathology and I went on this bonding retreat and sort of, and I brought along the dog. And toward the end, one of the young women doctors in training told me it was her plan, as soon as she passes her exams and is a real pathologist, she's going to buy one of these. So it really is something for affluent young women. And you may wonder about the development of robots. In the North American continent, it's mainly military-based, but in Asia, it's more based around care for the elderly and household tasks. So all the things that you'd like robots to be able to do for you, they will eventually be able to do, but probably through Asian source robotic development rather than the military developments in North America. Dr. Waugh and I went to see Blade Runner early in the history of this course. Of course, Blade Runner is biological replicant. So it's completely different. It's not silicon and circuit boards. Whereas the robot in the movie AI is silicon and circuit boards like this. So anyway, that's everything I have to tell you about the Sony Aibo robotic dog, and we'll now change over. Any questions about this?
So this is my daughter with Aibo, a different one. I have a shelf filled with these dogs, as you know. A question for you. Does your Aibo remember the trip to Leonard Cohen's house? And would it be able to interpret one of the songs of Leonard Cohen?
No, I think disappointingly, my belief is there's some trace there in the software, but I can't really find it.
Yeah, so let me close this guy. Go to my presentation, F5. Okay, again, good afternoon. My name is Osmar Zaiane. I'm a professor in computing science, and I specialize in data mining and machine learning. Okay, so this is the roadmap for the 3 lectures. In the past, I used to give 4 lectures, but I'm on sabbatical, actually. I'm not supposed to be here, but Kim managed to convince me, and I said, since I'm in town, I'll come and give the lectures. But I shrunk them to some extent to 3. And Patrick Pulaski will give the 4th one. I don't know exactly when in the schedule, but he'll do a very good job at presenting his part of AI. So the first part, I'll be talking about thinking machines and the singularity. I believe there was already a lecture on the singularity, the technological singularity per se. I'll revisit that idea and give my perspective without too emphasis on what I believe, but I will let you believe what you want. The second part, I haven't done the slides yet. I will reuse the previous slides. But I'll be talking about artificial intelligence, expert systems, and machine learning, how machines learn. And then in the third part, I'll be talking about data analytics. Okay, so we're talking about intelligent machines, so machines that think. What are thinking machines? Thinking, what is thinking first? We think, we take it for granted, and we do it all the time. Thinking is basically reflecting on a given situation and reasoning about the experience we saw before or we heard of, and then we make rational decisions given the situation we're in. So we as humans, we have this conscious mind, and we think. So humans exhibit this rational, objective, and conscious mind. Do animals? Do machines? So what do you think? Do animals think? Yes. Who doesn't believe that animals think as well, like humans? I've seen it many times. Actually, I can show you a video of a dog pushing a chair to climb on it in order to reach the table to eat something. That's thinking. That dog reasoned about using tools, the chair, in order to climb because that dog couldn't jump. Okay. So animals think. Do insects think? We don't know. Do they have a program in them so that they do what they do, or do they actually think based on the situation they're in? We really don't know. I witnessed a scorpion committing suicide. I don't know if you've seen this game that some people do, or some kids actually do. They have the scorpion in a circle of fire. So they put fire around the scorpion, and when the scorpion realizes it cannot escape anywhere, it kills itself. Is that thinking? Is that a reflex? They don't think, they just do it because it's programmed in them. We actually don't know. I don't know, anyways. Now, do machines, or can machines think? That's a very interesting question. I'll get back to that later. We can ask the question as well, can we program thinking, the property of thinking inside a machine? Okay, the machine, of course, doesn't come with the thinking property. Can we put it inside? And if a machine is thinking, can we say it's an intelligent machine? In that case, what is intelligence? And if it is intelligent, the ultimate question is, can it become more intelligent than a human? Can it become more intelligent than us? Okay. Let's think about creating life. I put it between quotes. Who has seen the Strand Beast? One person, two. Oh, interesting. So I discovered it watching a TED talk. And Theo Jansen, he's a Dutch guy who is fascinated by PVC pipes, and he uses these PVC pipes to create creatures. And he claims he's creating a new form of life. Let's look at it and see. So this is an animal, between quotes, that can feel, has a feeler, has a brain, can count, and make a kind of a decision going backwards to escape the water, so the tide coming in. So it has the instinct of survival programmed in it. And Theo Jansen was talking about evolution. So who plays the role of evolution here? Himself, yeah. He is the evolution. He's creating new, different. He's talking about the chromosomes, but it's actually his experience doing other beasts. He's trying to improve them and so forth. Is this strand beast a living thing? I'm trying to get you involved here. Yeah. No, why not?
Just because there's nothing about it that has the capacity to grow beyond what the maker has already put into it, I think. Okay. At least that's from my observations.
Okay, so it doesn't grow. Yes, that's a good point. You have another opinion there.
I think it's not living because it can't reproduce by itself.
Yes, it doesn't reproduce. Yeah. It doesn't grow, doesn't reproduce. It doesn't learn. If it miscounts once and it's half, to the knees, if it has a knee in the water, will it learn next time not to do the same mistake? No, it doesn't learn anything. An animal would learn. We all know Pavlov, so we can teach something to an animal somehow. It doesn't heal itself either. If it breaks, it breaks. It's dead, gone. Does it think? Or does it have the capacity to become intelligent? It has a brain. It counts. It's like a computer. It has a binary kind of code. Is it thinking? Does it think? Yeah, people are shaking their heads. Okay, you're hesitant. Well, let me do a small demo here. You know what this is? Yeah, it's a car. Okay. Well, it's a reproduction. We were reproducing a car. It's a toy for kids. If I give it to a kid, can you imagine the kid breaking it? Yes. I mean, the child is a human, and we are inquisitive. We want to know, and we break it. Is it breaking it to break it? Well, actually, many kids break these toys to understand how they are made inside, and they try to put them back together. So we're doing reverse engineering. Okay? We're trying to understand how things work. If I give it to a dog, it'll chew on it, and not necessarily to know how it works. They don't know what it is, actually. It'll chew on it to feel better about, I don't know, its teeth, clean its teeth. Now, if I ask a child, can you reproduce, they know what this represents. It's a car that is sitting in the garage. But if I can tell them, hey, can you now, here are pieces of Lego, can you build a car? I just asked my son this morning, and literally in 5 minutes he did this car. He loves Lego. It's not reproducing a car that exists. Maybe this one, yes, I don't know. But this one is not, but it looks like a car. Okay, so my son at least, he broke enough of these cars to realize how they work and the wheels turn, and so they built something like that. Okay, we can reverse engineer things and try to reproduce them. We can rebuild them themselves after putting them put them apart, but we can create something else based on the experience we had reverse engineering other things. Okay, like this car. This car was never built before, and he built it based on his experience. Now, something funny. Do you know what this is? It's a water flosser. Okay. It happened that somebody gave it to me to reverse engineer because it was broken, and I fixed it for them. So I said, hey, I'll borrow it for my class. I never built one of these, but I can use a screwdriver. I know what a screw is. I open it, and then I discover what's inside. I can guess what it does. There's a pump. There's water you put in here. It comes down here. There's a valve to stop the water from leaking. And then there's a pump. The pump sucks water on one side and pushes it along this tube. It's actually quite simple. So I was able to open it, fix it, and close it again, and now it's working. I'm sure if I give it to any one of you, they can do the same thing. Okay. If it breaks, well, we can rebuild something like that. We humans, we are intelligent enough to rebuild something like this. Maybe not exactly the same, like this is not like the first one, but something that plays the same role. Okay? I just need a pump. I need a container of water, be able to suck the water from that container and push it along a pipe. Okay? Squeeze it through a nozzle, like something like this. Okay? If I don't have a pump, I can't buy a pump, I know what the role of a pump is, I can build a pump from other things that I can buy from other stores and build a pump. Okay, something that turns and sucks on, creates a vacuum on one side and pushes on the other side. I can create one. Okay. So again, my message here is if I want to create something like this, I can do it. I just have to reverse engineer it, understand how it works, and then build something similar. Now, if I want to build something that is similar to a human, with its intelligence and everything that it can do, I need to do this reverse engineering task. It's possible, and make it like us, meaning intelligent. But we need one condition. The condition here to build this thing is that I understand how it works. I needed to understand that I require a pump. I needed to understand how the pump works, and so forth, and I can build something like this. For the human, it's the same thing. I need to be able to understand everything in the human body in order to be able to reproduce that, or at least mimic it, make it look like a human car. Of course, I cannot sit in there and drive, but eventually I could, with a lot of effort, create a car where I can sit in with Lego. I can create it with something else too. There are many people who created transportation devices in their own garages. It's not a car, but they know how to build them because they know how a car works. So to reverse engineer a human body, we need physicians, we need doctors, we need medical engineers. Okay. That is why we have a course like this one, actually. That's the most important part. Okay. So the message that I'm trying to give you is that we need doctors in order to better understand how the human body works, in order to be able to build something that is as intelligent as us. Okay. It may not look like me with 2 arms and 2 legs. It may have 6 legs and some wheels and some metal and stuff like that. I don't care. But it exhibits the same kind of intelligence. Okay. So first condition is that we understand how we work. Unfortunately, we still don't know everything about our human body. Many things, we have no idea. Okay. So not only we need doctors, we need biologists, we need philosophers as well. We need all sorts of people with different skills to be able to do what we're trying to do. Okay. Any questions about that? Or any comments about that? No. Okay, we'll leave the comments at the end then. I think this is the most important message that I can convey to you for this whole course. Can we program machines that think? That's the interesting question. It's not a new question. Many people have asked that question for centuries and have failed, of course. But they built things, they cheated. So, for example, this is a very famous machine called the Turk. It was commissioned by Maria Theresa Impress of Austria, Hungary and Austria at that time. It was built supposedly to play chess. So it's a machine that can play chess against humans. So if it can play chess automatically, it means it thinks. And people believed that this machine was working. But I can show you here, oops, some pictures. The machine was reproduced recently. It's in a museum. Here's the machine. So basically, there are 3 doors. One of the doors shows a mechanical device. Actually, it's programming a kind of a doll here to move and move the pieces of the chess on the chessboard. But actually, the 2 other doors reveal an empty space. That's where actually a human being is hiding. And I don't know if you can see the picture of what they see. This is what they see inside. So they see the chessboard as well, and they see where the pieces are, and they can move them from the inside. So it's actually a human being who's playing chess against the other human being. And those who are looking from outside, they think it's the machine itself that is making that decision and making those moves. Another interesting, oops, where was I? No. Another interesting, very old machine, also from the 18th century, is this machine that you can see in a museum in Neuchâtel in Switzerland. This was made by a Swiss clockmaker. He's actually the inventor of the watch, the wristwatch. And he built this doll that can write. The interesting thing is that in the back of this doll, there is a disk that you can change. And by changing the disk, it can write something else. It can write in different languages, different, well, we'll not call them fonts, but different handwritings. So it's actually a programmable machine. Maybe this is the first programmable machine, first computer, if you wish. Okay, the program was that disk, which is actually quite impressive. So this is not fake. The Turk is a fake one, but this is not fake. This is just to show you that people have been fascinated by thinking machines for centuries already. This is not new. But in reality, we still don't know what it means to think. Okay? So we look at the machines today. It's not a doll anymore. Okay, so here are machines. These are old pictures from the 50s, and this is in the 50s with vacuum tubes. And I chose it on purpose to show you that the first computer operators were females, actually. First computer scientists were females. I don't know why, and we don't have many anymore. I wished we did. The other picture is from the 60s. This is the first computer using transistors. And the evolution was incredibly fast. I put here 3 curves here, but actually it's exponential. Here I have pictures of new computers. They don't use vacuum tubes anymore, and the transistors are not like this anymore. They are cramped on a chip, billions of them on a chip. Okay. So if I look at the evolution of the size, or the evolution of their density, it increased exponentially. I don't know if you can read this. This is very small. The size in the 1970s, I got this data from Intel. Intel is the company that creates one of the chips for the PCs and the tablets. So in the 70s, the transistor was 10 microns. In 2007, it was 0.045 micron. So you can imagine how small it's getting. Very, very, very small. In 1970, we were able to put 2,300 transistors, these are transistors, on one chip. 2007, a billion. A billion. We'll get back to those numbers soon. Tell you what it means. What is a billion? It's very difficult to actually imagine. Okay. So indeed, they evolved very rapidly, and the capability of this machine that you see here from 1970 and 1960 is inferior to the computer that I have on my wristwatch today, just to give you an idea. I mean, the evolution is phenomenal. However, what we have to keep in mind is that the hardware has evolved. Software, it's lagging behind. And software is what is making the machines do what they do. Without the software, the hardware is just a piece of metal and silicon. Okay. So if we want machines to think, we shouldn't only consider hardware. Hardware is important to make all these calculations very fast. But we have to also think about software. That's where AI plays a big role. Okay. AI meaning artificial intelligence. Here's an interesting graph that a famous computer vision guy presented. This is Hans Moravec. He's an Austrian computer vision specialist, but he's also transhumanist, so he believes in cybernetic singularity. So he's showing here how computers have evolved. And what is interesting is that the trend has been revisited again and again. So each time, so this is the trend we had in 1965 based on that evolution at that time. And then in 75, said, oh, no, actually we're going even faster. In 85, said, no, even faster than that. In 95, said, no, even faster than that. So we are continuously revisiting this target that we are targeting, which is having computers that have the capacity to think like humans. So this shows the number of instructions per second, million instructions per second, and the cost to build such capacity is going down very rapidly. Okay. But again, don't forget, there's a difference between hardware and software. Hardware, yes, is going forward. Software is not yet. Just to put things in perspective, who knows what this is? 1, 2, 3. It's not a CD. This is what we call a floppy disk. Okay? So these were 5¼ inch. This is not a 3½. I'm not talking about the plastic ones. This is earlier in the 80s. And there were 2 versions. The first version was double density, and it was able, the capacity was 360 kilobytes. Okay? In 1984, IBM managed to add more capacity to that floppy disk, and it was called the high density, HD. And we were able to put 1.2 megabytes. That was amazing. I can tell you that I was able to put my operating system, my software for word processing, and my thesis on the same floppy disk. That was incredible. You can't think of that today. Do you have any idea how much that was? In terms of money, how much did it cost? So in the 80s, the double density was $3, and the high density was $5 if you buy it by the unit. You can buy 10 in a pack. But if you buy by the unit, that was the cost. Well, 2 years ago, I was in Singapore, and I bought a USB like this one. 64 gigabyte. That was incredible. Say, wow, 64, I've never seen one like that. I'm going to buy it. How much did I pay? $32. $32. So if I extrapolate, at $3 the 360 kilobyte, that USB, had I purchased it in 1980, would have cost me more than $500,000. That puts it in perspective. That means that I have $500,000 in my pocket. I have a house, a very nice house in my pocket. Amazing. Okay. Well, I'm not the only one trying to do this parallel between the past and today. I found, I get back to that. I want to just give you an idea. What does it mean that I have 32 or 64 gigabytes in my pocket? What is a gigabyte? So now it's part of our language. We talk about gigabyte. I'm buying a phone 16 gigabytes or a pad for 64 gigabytes. What's a gigabyte? Okay. So a gigabyte is a billion characters. Okay, so it's 1 with 9 zeros. What does that mean? Well, I'm a swimmer, so I know what swimming pools are. And I want to give you an analogy with swimming pools. If I take an Olympic swimming pool, and this is the Olympic swimming pool from Beijing during the Olympic Games, to give you an idea about the size, it's 50 meters long by 25 meters wide. That's a mandatory rule by FINA, the International Federation of Swimming. The depth may vary, but on average, it has to be deep enough so that you don't have too many waves on the surface. So on average, you have 2.5 million liters in that swimming pool. Okay? So if you know that a liter is 20,000 drops, that means we have there 50 billion drops. So that's 50 giga drops. So I don't just have a house here, I have an Olympic swimming pool in my pocket. Okay. So that gives you an idea about what it means to have 50 gigabyte. It's a swimming pool of characters. Each drop is a character. Okay. That's huge. So other people have made the parallel, as I said, between the past and today. So this is a picture I got online. They are talking about a rack of disks in 1956. IBM was shipping it to another place, to a company that purchased it, and it was so big deal that even the captain of the plane was there for the photo op. Okay. That was a 5 megabyte disk. And that 5 megabyte disk in 1956 was $120,000. Okay. Now compared to a micro SD card that you buy for your phone or for your camera or whatever, you can buy a 64 gig for $60. So if you use the consumer price index and inflation rate, that $120,000 is equivalent to $1 million today for that 64 gigabyte. Okay. So that shows you the progression. And not only we can cram way more than what we have in that big rack in a small tiny thing the size of a fingernail, but the cost dropped significantly. So we can build these big machines. Okay. Let me scare you further. I talked about gigabytes. I just purchased this. I was in China in December, and I found this and I couldn't resist. I had to buy it. A USB key with 2 terabytes. And these are pictures that I took myself. So I show you how when I purchased it, I put it on the computer to see that I really have 2 terabytes, and indeed I have 2 terabytes. I won't tell you how much I paid because you'll be really jealous. Less than that 64 gigabyte that I purchased in Singapore. And I remind you that a terabyte is 1,000 times a gigabyte. Okay, so I have way more than a swimming pool and a house in here. Okay, so basically it is changing very, very rapidly. But again, this is hardware. It's not the software. And where we are missing, well, we need to put more effort basically on the software to take advantage of that hardware, the amazing hardware that we have, in order to hope one day to build intelligent machines. Let's talk about another kind of evolution. Do you remember these bricks? That's the first cell phone that went public in the 80s. The price of that brick, and it was called the brick because it was the size of a brick, the price, you'll be surprised, was $4,000. $4,000 for that huge phone, 1983 from Motorola. Well, the cell phones have evolved significantly since then, and now we have these smartphones. Everybody has a smartphone in their pocket, and they remain in our pocket maybe 1 year because the year after there's a better phone and we dump the old one and get another one. They evolve so fast. So in medicine, they have been used because they evolved so fast that this smartphone that I have in my hand is more powerful actually than this laptop, believe it or not. So we are taking advantage of this, this hardware, and people are building software. So here are examples of software running on cell phones that can help doctors. An application on a smartphone that can detect arrhythmia, so cardiac arrhythmia. An application for ultrasound machines, so you can check the baby in the womb. Another application for blood pressure measurement using a cell phone. Another application for eye exam to check the retina. Another application to check for ear infections. So it's the same machine, but you just, well, either you take advantage of some of the sensors that are already built in, or you add some of these extensions. There are applications to look at CT scans on a phone and share those CT scans with colleagues far away for different opinions or whatever. This is oximetry using the cell phone. This is a very interesting application where they do telemedicine, so consultation using the cell phone during surgery, okay, real time. You all remember Star Trek, the tricorder that can do everything? Well, there are people who are trying to build tricorders. Here's one by a scientist from NASA who created what he called the first real tricorder, is not a fake, because there are many fakes that you can buy in a toy store. This one can detect dangerous chemicals and gases and so forth in the air. Okay, so you add basically additional sensors that you plug in your cell phone, and then your cell phone becomes a tricorder. Who knows about the pomegranate phone? 1, 2. Nobody knows about this. Okay, well, I'll show you. Do you want to know about the phone? You interested? Okay. It's a very effective ad for Nova Scotia. But actually phones that, this was a few years ago, and people were, from the beginning, already laughing, saying, this cannot be a projector. But there are now phones that have a projector in them. I have a small projector. It's not a phone. It's this size, indeed, with LED projectors. Also, phones that you can talk to and can translate, it exists already. Well, shavers and coffee machines, that's not there yet. But just to give you a demo, OK, Google, who's Vladimir Putin?
According to Wikipedia, Vladimir Vladimirovich Putin is the 4th and current president of Russia, incumbent since the 7th of May 2012.
So it can answer my, I don't even touch it. It knows that I'm talking to it, and decides to react and give me the answer. OK, Google, what's the weather like?
It's 1 degree and clear in Edmonton.
It knows that I'm in Edmonton, so it looks smart, it looks intelligent, doesn't it? Actually, there's nothing special in there. There's no rocket science whatsoever. It's very simple. What you need is speech to text first, and then once you have that text, it becomes a query that is sent to a search engine, and then you get some answers, you extract some information out of that, and then you have text to speech, and then you hear it back. So for a few years from now, we'll realize this is nothing. Today, it's new. Wow, it's intelligent. Okay. So what we consider intelligent in machines is changing. If I go back a few years ago, when we moved from a typewriter to a word processor, the word processor was able to justify the line and add enough spaces between the words automatically. You say, wow, that's amazing, because we used to struggle with the typewriter to do the justification, and that was hard. Then the word processor was fixing our mistakes, our spelling mistakes. Wow, that's intelligent. Who thinks today that a word processor is intelligent? There's no intelligence in a word processor. So the meaning of intelligent in a machine changes in time. What we consider today intelligent, tomorrow will not be. And intelligence is something higher and higher. Okay. Let me go back to the presentation. No. So let's go to the singularity, the idea of singularity. It's singularity, we now use singularity to mean technological singularity, but singularity existed before. So in math, singularity has a meaning. It's a point where you cannot get the derivative, so the derivative is non-existent, but when you look at the neighborhood of that point, there is a derivative. Okay, so it's a point unusual, an unusual point. That's why many artists represent it like this, with this is the point where there's no derivative, it goes to infinity, while the others have a derivative that is finite. In astrophysics, singularity has a meaning as well. That's where the density of matter becomes infinite, and everything is attracted there. That's what we call the black hole. That's a singularity. So technological singularity, I'm just reminding you, I'm sure this was addressed in the lecture on singularity. It's basically the time when machines, so the most intelligent entity on Earth is a machine, not the human being anymore. So that machine will drive technology, and when that happens, we cannot predict what will happen afterwards because it'll go so fast. And it's beyond our intelligence, and that's why it's a singularity. Okay, we call it singularity. So to better understand why is actually called a singularity, I'm using this example that I've used in the past. If I look at the mouse is a living thing, okay? Not like that strand beets, that is not a living thing. This mouse is a living thing. It can reproduce, it grows. If it's injured, it can heal itself. It thinks, it's actually intelligent. It's intelligent because, for me, I consider it intelligent because it adapts to its environment. Okay, it's not just programmed and that's it. It can adapt. And indeed, if there is a flood, that mouse will swim. If food is on the other side of the river, that mouse will cross the river to go and get that food. Okay. So it knows where to find its food. The food is not always in one place. It will adapt to that environment to go and get it. It is intelligent enough to adapt. When it has offsprings, it needs to build a nest, and that nest each time will be different depending upon what exists in that environment. If it's in the field, it'll use vegetation. If it's in my garage, it'll use some newspapers and cardboard and plastic. And actually, at one point, I had a mouse in my car engine, and it used the insulation. It munched on that. Cost me a lot of money. So it's intelligent because it knows what is appropriate for the nest, and it'll use it. A mouse, if you put it in a maze and you put some cheese at the end, it'll find its way in the maze to get that reward. It'll stumble, find some places where it can't go forward, it'll go back, and so forth, until it finds the cheese. If later you put it back in that same maze, it will know how to go directly without going in these cul-de-sacs. Okay. So that's intelligence, because it uses its own experience to react to that environment. You can actually conceivably teach a mouse how to count. And I'm guessing it knows how to count. If it has 4 babies and one of them dies, it will know that it has only 3. Okay? So they know how to count, but you can actually ask them to count. I've seen dogs counting, parrots counting, and things like that. So an animal can learn how to count. So do you agree with me that that being is intelligent? Yes, okay. Now, if the mouse is outside at night, gazing at the sky and seeing the stars, can you conceivably imagine the mouse reflecting on these stars and imagining whether those are planets or not planets, whether they're solar systems? Are there other mice living in another planet? No. I don't believe so. I don't know what the mouse thinks. These are holes in the sky or light bulbs, or I don't know. But certainly not thinking that there are other planets and other living things in other galaxies. Maybe that's too big if I go in a smaller world. So will a mouse think about protein and cells and things like that? Probably not. So that mouse that was in my garage and built a nest in my engine, car engine, did it know what an engine is? What is it used for? The different components. The only thing it knows is that it's warm. So it's a source of heat, and it has enough stuff to build a nest. Okay. Same thing applies to a rocket ship. It has no idea what that rocket ship is and what is it for. Now, we said that the mouse could conceivably count. Can it do abstraction and learn mathematics? No. So the mouse is not like, it has a brain, it's intelligent, but it doesn't have our intelligence. and the mouse cannot understand our intelligence, cannot imagine, cannot describe it in its own way. We can understand and describe how the mouse thinks and what is its level of intelligence, but the mouse cannot imagine or comprehend our intelligence. It's beyond it. Do you agree with that? So there are different levels of intelligence. There is the human being, and I'll put it at scale 0. Anything that is sub-0, so underneath 0, it's not as intelligent as humans. But that means there could be something that is more intelligent than humans, super intelligent. Maybe one day a machine could become super intelligent. And that means that we, humans, at level 0, cannot comprehend that intelligence, like the mouse cannot comprehend our intelligence. So we are intelligent enough to realize it could be another intelligence, but we don't know what it is and how it will be. Does it make sense? Okay. Okay. I think that's an important concept to understand. And this is actually why we are calling it singularity, because the day the machine goes beyond the 0, it's in the positive side, it will be the one doing these innovations. It will be the one thinking. And we can't predict what it will become. So it goes to this infinity. And how fast it will be, we don't know. The machine will improve itself because it's more intelligent than us. It knows what to do better than us. Okay? So this technological singularity is this hypothetical future, hypothetical because we haven't proven it. We either believe in it or we don't. So the hypothetical future emergence of a greater than human intelligence, and we believe that this will come through technological means, and because it's more intelligent than us, it probably will result in this explosive superintelligence. It'll grow very fast. Okay. So we could one day indeed have something, whether it's a machine or a machine, a human, whatever that combination is, that could be more intelligent than humans. And this entity will then solve our problems better than we know how to solve them, and design other machines with better capabilities and so forth. That will become recursive. Okay. So singularity is this recursive, rapid self-improvement, and it grows, grows, grows very fast. So since we cannot comprehend that, we cannot predict it. Hence this singularity. Okay. Now, is it just science fiction? We will see them in books and movies, or is it reality? It's up to you to judge that. But my advice is that whether it is true or not true, whether it will happen or not happen, and whether it will happen in our generation or the next generation or in 10 generations, the important thing is that we should not dismiss it, and we should think about it and think about the consequences of that and the advantages of that. So I believe Dr. Solis talked about 4 main paths to this singularity. I will revisit them here, and I'll just give my take on that. I order them in a different way. So one path is to find ways in biology to improve upon the natural human intellect. So we know that natural selection is, if we believe in evolution, is very slow, takes generations and generations. Can we help nature so that biologically we will improve, at least in the intelligence side? So people are talking about helping the natural selection by, well, selecting at birth Whether it's ethical or unethical, that's another question. But selecting at birth, for example, people that have more capacity for this or that. I think it's not realistic. If you take people that we know are smart, Albert Einstein, for example, born in 1890 something, I forgot, so in the 19th century, and Aristotle, born in the 4th century BC, is one more intelligent than the other? I don't believe so. I think they have the same intelligence. They have the same capacity to think about things, except one knew more than the other. One took advantage of the experience of all these generations in between them. Okay? So if Aristotle was born in the 19th or 20th century, he could have also achieved the same things as Albert Einstein. So intelligence hasn't evolved, okay, naturally. Can we make it faster? Okay, that was the question, and I'm skeptical on that. The other path is create an artificial intelligence that exceeds human intelligence. So building a machine, maybe this phone will become more intelligent than me. It's possible. But here again, there's this dilemma, hardware and software. Hardware is evolving very rapidly. Software is very slow, lagging behind. And I will not be able to build an intelligent machine, even with the best hardware in the world, if there's no software for it. Okay. And for machines to be able to have that software making them more intelligent than me, you have to have another condition. The machines will have to be able to write code to self-improve themselves. And there's another issue. What about self-consciousness? So I know that I exist. Does the machine know that it exists? I'm turning it on and off. And, well, there are many people who are discussing this, and they wrote books about that, and you can see them in movies, science fiction movies, about this issue of self-consciousness. But it's a very important piece that we have to consider if we want to build a machine that is more intelligent than us. Then the other path is create a human-computer interface, so connection between machine and humans that will enable us to have, well, to use our capacities better than what we are using them. For example, this famous Einstein claimed one day that we are actually using only 10% of our capacity, brain capacity. Maybe we'll have medical means or mechanical means to help us use that 90% that we are not using, and we will become more intelligent. We don't know. So these are hypotheses. But there's transhumanism is a movement that is actually getting stronger and stronger. You have many people believing in this, and what they believe in is that we can enhance humans to become better than what they are today. So they are studying emerging technologies that could overcome fundamental human limitations, whatever those limitations are. Okay. And the final path, the fourth path, is build large computer networks in which beyond human intelligence may emerge somehow. Some other people believe in this fourth part. I can tell you that I'm skeptical on the first, skeptical on the second. I'm a believer in the third and fourth path. I don't know how in the fourth path it will happen, but today we're already seeing the Internet of Things. Have you heard of the Internet of Things? Who has heard of the Internet of Things? Yeah, the two. So a computer to connect to the Internet needs an address. Okay? So our address was very limited. We used IP version 4. We are reaching the limit of the IP addresses. We cannot add more machines. So we have a new version of IP called IP version 6 that allows billions of addresses. So now that we have these billions of addresses, we can put them on everything. I can put it on this car. I can put it on a light bulb. I can put it on a camera. Anything can be connected to the internet. So these are the things can be connected. And why do you connect them? For different reasons. I can remotely turn on and off that light bulb, for example, or remotely connect to this phone or other things. Okay. Now, when all these things are connected and all that information is known somewhere, is there a possibility that some intelligence emerges from that? It's possible. We don't know. Okay. So I'll show you another interesting video that, oh my. Okay, we'll stop with this video. I think it's a very interesting video. Time passes very quickly here. So this is about ants. The interesting thing is that one ant doesn't even know all that whole city, doesn't even know where the different tunnels are. But the whole group, the collective, becomes thinking. So this Internet of Things and this big internet, from that, with the hardware and the software that we will build, something may emerge out of that. We don't know. And on that, I thank you, and hopefully we'll have a discussion next time.
More to come a week from today. Great, thanks very much.